In this lesson, we're going to talk about scatter plots and lines of best fit. So first, let's talk about what is a scatter plot. So a scatter plot is just like plotting raw data. That's all it is. So if you have a collection of data that has like hours after sunrise and the temperature, you just plot it. Oh, 2 hours after sunrise, it's 62 degrees. 6 hours after sunrise, it's around 68 degrees. So you just plot all your information and you see what it looks like. That's a scatter plot. Just plot your data. And when that happens, we want to understand the association behind it. So sometimes you have stuff like this, where as your x increases, so does your y. We call that a positive correlation. So an example here is hours at the sun time and the temperature, right? As the day goes on, it usually gets hotter for the most part until it cycles. But that's a positive correlation. A negative correlation B is when it's as x gets higher, y goes down, right? So as x gets bigger, y gets smaller. So the temperature after sunset, once the sun goes down, right, starts to cool off. That's a negative correlation. And then sometimes we have no correlation at all. Just there's no general trend to the data. So in this case, it's rainfall after sunset. So the hours after sunset and the rainfall, there's no correlation. Sometimes it's a lot. If it's raining that day, sometimes there's no rain that day. There's no correlation. We call that no association. So those are 3 ones. We have a positive correlation. We have a negative correlation. Right. So positive correlation is as x increases, the y increases also. Negative correlations as x increases, the y decreases. And we have no correlation. And even within that, when you eventually do more stats, you talk about like how strong the correlation is and how weak it is and stuff like that. It goes more deep. So anyway, let's quick example, right? So if I was to ask you what type of association this would be, I would say this is a positive association. This one, see, it's all scattered all over the place. I'll say no association or none. And then here you can see it's like a negative association. So that's how you tell what type of association it is. Is it increasing? Is it decreasing? Is it all over the place? Okay, now let's talk about correlation. Let's talk about understanding correlation. And all correlation is a way of saying, is there a relationship between these two things? That's it. So it's like saying that in a single word. Is there a correlation? It just means, is there a relationship between these two things? And one way to tell is when you do a scatter plot, if it looks linear, then we could do what's called a trend line. And that'll let us model the relationship between the two things. So in this case, right, temperature after sunrise, right, we have the scatter plot. It looks like it's a linear relationship, so we could draw what's called a trend line. All you're trying to do is try and get like kind of in the middle. There's no one right answer here. You're trying to get in the middle of all those points. And if we actually do get a linear trend line, you know what that means? That means we can make an equation out of it. Right? If it's something we can make an equation, and that lets us predict things. Right? Equations are very powerful. If I'm able to make an equation out of this, then we can predict what the temperature is going to be after 11 hours or at 6.5 hours. So that's the power of mathematics and the power of correlation. Is if we make a trend line out of it, then we can start predicting things and using it to find stuff. So this was a positive correlation. Right here, if we're looking at this next one, right, temperature after sunset. That one, you could draw a trend line that kind of looks like this. Again, keep in mind, there's no one right answer for a trend line. It could be like that. It could be a little bit more like this. There's going to be lots of different answers. But this will be a negative correlation. But just like before, we would be able to find an equation for that line. So let's do that next. Let's write an equation of a trend line. So let's talk about how to do that. So in this example, we're going to do what trend line models the data in the scatter plot. So we have electric hybrid cars sold. So starting in the year 2000, and then number of cars sold in thousands. So step one of trying to like make a model for this data, like a model is, when you talk about a model, we're talking about an equation, right? An equation for the trend line. That's all a model is. Okay, and to do that, step one would actually be is plot your scatter plot, right? So if they give you a table of values, then you have to plot your scatter plot first. In this case, we already have a scatter plot, so nice. Step two will be sketch a trend line for the data. So again, there's no one right way to do this. What you're trying to do is trying to get kind of in between like most of the points. So again, there's no one right way. Let's make something like this. Notice how I don't hit all the points. The trend line might not pass through any of the data points. You're just trying to get a point that's kind of in between, right? It's an estimation. That's why there's no one right answer to this. So after you sketch a trend line, we're going to want to write an equation of a trend line. Well, it's the same way we always write an equation of a line. Y minus y1 equals m times x minus x1. Point slope form for the win. Right? I love this equation because it makes writing equation so easy. So if you remember how we do this, we got to find two things. We got to find the slope, and we got to find a point at x1, y1 point. So remember how to find a slope? It's always the same. You got to find 2 points. No matter which way you find the slope, there's lots of ways to find the slope, right? Rise or run, difference in y over difference of x. Using the slope equation, either way, you have to find 2 points. So in our trend line here, we want to find 2 points that cross nicely. That's going to be kind of hard to see, but I'll tell you one point right here that crosses nicely. You kind of see there's a faint grid. That point is like 2 and 50. Again, the trend line is not going to hit might not hit the points you have. You just want to graph it on your grid and then see what points on the grid you could actually see. Like, okay, so I see that one. I might be able to use this one. I'm gonna use this one right here, right? So you just look at your grid, independent. Like once you make your trend line, the scatter plot doesn't matter anymore, right? You're just looking at your trend line. So I'm gonna use the point right here. That looks like 16 and 500. So there we go. So those are my 2 points. Now I gotta find the slope. I could do rise over run. In this case, they're so far apart, I'm going to use the slope equation. Y2 minus y1 over x2 minus x1, right? Let's say x1, y1, x2, y2. So I'm going to get 500 minus 50 over 16 minus 2. I'm going to get 450 divided by 14. So that's 450 divided by 14, which gets me about 32.1. I'm going to round it. So let's say 32.1. Like that. Right? So that's my slope. Now I need a point. Well, we have 2 of them. So pick any one. I'm going to pick the smaller one. That's probably a little easier. That'll be my 2. That'll be my 50. And all we have to do now is simplify. So we get y minus 50 equals 32.1 x minus 2. Let's distribute. So y minus 50 equals 32.1 minus 64.2. Almost forgot the x. Don't be better than me. Don't forget the x. Right? And let's try to get the y by itself. So let's move it over. So we want a linear function. So we're going to get the y by itself. So I'm going to get y equals 32.1x minus 14.2. Keep in mind, there are many solutions possible, right? It depends how you draw your trend line. So many solutions. Now they're not all right. Like if you draw your trend line like negative, it would be wrong. But there's many solutions. Also, don't forget stuff we learned before, right? If I want to know what the slope was, remember slope, like if I'm trying to interpret the meaning of slope here, slope is always y over x. So what is y? Y is cars sold, 1,000 over the years. So cars sold over years. So in this case, right, it's a positive slope. So we're selling 32 more cars per year, right? Remember that lines up per. So plus 32.1 cars and thousands per year. Right? It's not just 32, it's 32,000 more cars per year. So every year we're selling 32 more thousand cars, right? And remember what our y-intercept means? Negative 14.2. So in this case, it doesn't really make sense. So it will say we're selling negative 14.2. That's where we started off at. But keep in mind, it is just an estimation since we're doing a trend line. That's the idea of that. Okay, let's go on to the next one. Let's try another one here. So we're going to do the temperature after sunset. So same idea, right? We're going to draw a trend line here. So again, you're just trying to kind of get in the middle of them as much as possible. It's kind of the idea. There's no one right answer. And then you want to look at the line you drew, like ignore the points and just go, okay, where did I hit it nice? Where did I cross nicely? So it looks like I crossed nicely there at 2 and 68. And then also at 7 and 62 right here. Right, so you're just looking at the grid line to see where you cross the grid lines nicely. So if I was going to do our equation again, right? We want to make equations y minus y1 equals m x minus x1. Now last time I did the slope, I used the slope equation. This time I'm going to do rise over run. So I'm going to go from there to there. So we're going from left to right, like that. We went down 6, minus 6, right? I went from 68 to 62, so down 6, and I went over 5. So my slope using rise over run would be -6/5. So again, this time I use rise over run. Last time I used a the equation for slope. Either way is fine. Once you find your 2 points, you can do any way you want. So this would be -6/5. I need a point. Let's use the first point. So 2 goes here, 68 goes there. We have y minus 68 equals -6/5 times x minus 2. And if we distribute this, we're going to get some decimals. That's what happens when you do real life problems. Decimals come up. Let's make that a decimal itself, right? So I'm just make that a decimal for ease. And that's going to be plus -1.2 times -2 gives me a positive 2.4. Just like that. And then let's add 68 to both sides to get the y by itself. And we're going to get y equals approximately -1.2x plus 70.4. And that'll be our equation. So again, answers will vary because it depends how you drew your line of best fit. And again, if I was talking about what the slope means, in this case, -1.2/1, what's our y, right? Temperature. So your temperature is going down 1.2 Fahrenheit every hour. That's what the slope means. And our y-intercept is our initial value, right? Our initial value here was 72, or actually in our trend line, 70. Okay, one last one. The table shows the amount of time required to download a 100 megabyte file for various internet speeds. Assuming that the trend continues, how long will it take to download a 100 megabyte file if the internet speed is 75 kilobytes per second? So give us a table here. So step one is you actually got to plot the table, right? So this is like starting at the very start. Like, hey, we have some data. Let's plot the data. So I need to plot 35 with 6.6. So 35 is around here and 6.65. So it's like around there. And then we have 40 with 582. So like around there. And then we have 45 with 517. So like around there. 55 with, or 50 with 46, 6.5. 55 4.23. 60 with 3.88. So something to that effect, right? But that's our step one. Step one is you have to sketch the scatter plot. Step two, let's make a trend line. So again, just trying to get, don't care about hitting the points, just trying to get kind of in the middle. What's the line that kind of best encapsulates those points? So I get something like that. Next, with our trend line, again, ignore everything else. With your trend line, look for 2 points. I'm going to say right here, we'll say that's 55 and 4. And it will also say 40 hit pretty much, well, my grip's a little off. It was supposed to be 40 and 60. That's what I was supposed to hit. Again, answers will vary. I'm going to use that just for ease. So those are 2 points. And again, just like before, let's write an equation for a trend line. We're going to go, okay, y minus y1 equals mx minus x1. Right, I need my slope. I'm going to do rise run. It's a little faster. So like that to like that. In this case, I went down 2, 6 to 4, so -2. And I went to the right 15, right? 40 to 55 is 15. So my slope would be -2/15, which is about -0.13. So let's go here, -0.13. I need a point. We'll just use my first one, 40 and 60. So x is 40, y is 60. Let's simplify. Y minus 6 equals -0.13, x minus 40. Distribute. Gonna need a calculator for sure. -0.13 x minus 2 negatives make a positive 5.2. If we put that in my calculator. And again, 0.13, 0.13, same thing. Let's add the 6 to both sides. Plus 6 plus 6. And we get y equals -0.13x plus 11.2. So that's the equation for this thing, right? So internet speed, it looks like it's going down 0.13 megabytes per kilobyte. The time it takes to download. So it goes a little bit faster. So that's our equation. And the next part is, what could I do with an equation? Well, we could use it to figure out how to find out when x is 75. So if my internet speed is 75, like I have a very particular internet speed, how long will it take me to download it? So in that case, right, we're just going to substitute it in. That's the beauty of this thing. So we substitute it in. 75 goes in for x plus 11.2. I'm going to put this into my calculator. And I get 1.45. So that means it's going to take 1.45 minutes to download at that speed. And that's the idea.